About competing square again, so this is one of the hot topic. We may just try to modify the given function and then change it to vertex form so we can get the vertex directly after we successfully transform it. We always handle x squared only. We can't accept -1/3. So among the first two terms involving x squared and x, we both extract -1/3. That means in reverse, both terms we have to times -3 here, so it gives us 1x squared. And then positive 20 times -3 is give -36x. After that, we have to identify what is needed in order to create a complete square. 2 something something. We have to think what inside will give us -36. That means 36 divided by 2, we get 18. So what we need is 18 squared. We can't simply add 18 squared, that's why we have to minus 18 squared at the same time. We successfully keep all the unknown variable inside the square. And then we just need to handle it by separating two terms. Both we need to times -1/3 when we remove the bracket. -3 to 4 here. And then just handle it very carefully. The constant term become -13, which means that the vertex of the graph y equal to fx is when this square becomes 0. That means when x equal to 18. Then the corresponding results of y is this part becomes 0. This is the only term for the results. So the result is -13. By observing this function, we know that first, the vertex is 18 and -13. This is opening downward, so it's like this. This is the graph. And if we extend it when x equal to 0, we know that the constant term will be the only outcome, so -1 to 1 here. That's what we know about this graph at this moment. In part B, they say that there is another graph, no longer fx, but we are talking about the height equal to gx. It's obtained by translate this graph, the original graph, vertically, such that the graph touch x-axis. That means we have to shift up so that the curve will touch this line, touch the x-axis. So they try to tell you that the graph is like this by shifting up. And then how do you know that how many units translate upward? You just look at the original height of the vertex. The height of vertex is -13. To make it reach 0, the new vertex is 18, 0 because they say it's touch. So the vertex will touch the axis. That means it's translate upward by 13 units. We have to find the gx, so we just need to write it down since y equal to fx translate upward. For 13 units. Therefore, gx is equal to fx and then the outcome plus 13. That means -1/3 x minus 18 squared minus 13, and then offset its result. So only the square term is left. That gx already, and we already finished part B. Now the last part is about part C, when this is changed to this function, that means maybe it's another function. Maybe you may call it hx if it is needed. We have to describe the geometric meaning of this transformation. The key point is you have to use fx, the original function, or this one, to express the new function here, so that you know by observing the change of the function, you can know what is the geometric meaning of the transformation. Part C, a new function, negative 1 over 3x squared minus 12x minus 1 to 1. Compared with this format, we observe the difference. The first term are the same, the last term are the same, but the middle term become different. So we know that we may try to express that something. We try to express in terms of negative x here. Bracket negative x squared is still x squared. Negative x times positive give you back negative. So now the structure are exactly the same as fx, but our input is not x, but our input is negative x. So that means this is f. We put negative x instead of positive x, which means that the new function, let us label it as hx. The new function is by replacing x to negative x, which means that this is refactored along y-axis. So we just write down the conclusion now. Therefore, the transformation is refactor y equal to fx along y-axis. That means we consider this is the mirror, and then compare with the black line fx. It is refactored like this, while the new vertex is negative 18, negative 13. But however, there is another method to solve these questions. Part C, negative 1 over 3x squared minus 1 to 12x and then minus 1 to 1. It's the same logic that we try to use fx to express this function. Another method is we try to perform computing square again on this function. And then after computing square, we find out this. Compare with fx. Compare with here, we find that the key point is what input. It seems that is 36 more than that inside the bracket. So we are going to make it look like fx. Fx is something minus 18. Now that something is x plus 36. If we use this logic, that means this is f. What inside is x plus 36. The new function is compared with we use the original function, but we affect the x-axis. 左加右減. That means plus something. That means you will transfer it to left hand side. So another conclusion is the transformation is translate y equal to fx to left hand side by 36 units. From this graph and also from the function, the transformation here are exactly the same outcome. Both of them give you the same image, which is the blue line here. To conclude, in part C, if you need to know the geometric meaning of the transformation, you must try to express the new function in terms of fx. Then by observe the fx, you know how does it transform.